Okay. First question was a disk rotating with the angular velocity of 4 radian per second. It is subjected to the angular acceleration of the 2 radian per second. We are looking for to find the acceleration at the point B. Look, this is a rigid body that's rotating. We have these equations for the exam. For example, I do not provide those ones in front of the question. You have to just refer to the equation sheet, find those ones. For this problem, the acceleration along tangential and normal is given of r, and you need to find them. But already, acceleration along tangential and normal, you can see they are 4 and 32. You need to calculate it, but you need to see what's the correct direction for this problem. Okay, for all of these ones, 4, 32 are equal for all of them, but the kind of the sign will be changed for option A, B, and C, and D. At the position B, this is the tangential acceleration. This is the normal acceleration. You do not need to also calculate anything. For this one, the tangential one, it is in opposite direction of the x. It is in minus. Means that C and D are the correct one. Now, also for the normal, normally it's along the y direction, positive. This is the correct answer. It takes 5 seconds. Got it? Also, if you want to calculate, alpha, it is 2. Radius, it is 2. Tangential acceleration will be 4 foot per second square. Omega, it is 4 square. Radius, it is 2. This one is 32 foot per second square, if we want to calculate. Similar to this one is for your homework 8. Similar, you need to find the acceleration, velocity, and this. The second question, if a rigid body rotates with a constant angular velocity about the fixed axis, the velocity will be omega cross product of the RP. This is not this one. Why? Because this one is equal to minus RP cross omega. And also, this is the general formula for definition of the velocity we are looking for when it's a rotational. Any questions? The correct answer for this, it is A. Any questions? No? Today, what I'm going to do, I want to solve examples regarding general plane motion. But let's review what we did before and also what you learned before. We started to talk about the rigid body. Rigid body is a body that has a size and shape, but the deformation is negligible. Then there are 3 types of the motion for the rigid body. Translational, what is the second type of the motion? Yes?
Rotational.
Correct. Rotational. And the last one is a general plane motion. For a translational motion, when a rigid body moves along a straight path or curved path, you learn that the velocity and the acceleration of any point inside of the rigid body are equal. This is for translational one, such as a car is moving along a straight path or along a curved path. For a rotational one, such as disk that is rotating. Some of you just, when I just read some comments about the velocity of the rotational body, look, this disk is rotating with the angular velocity of the omega. Then the velocity of it is at any point of this disk. This one is a disk, has size, has shape, but the deformation is negligible. To find the velocity of any point on this disk, we can find the velocity using omega r, the magnitude of velocity. That for this one is the distance from the axis of the rotation. Also, from this equation, you can find the magnitude. Also, you can find the direction of the velocity. For example, at this point, the velocity is downward. To find the direction of the velocity, you can use this equation, omega cross product of the r. Also, the acceleration that we discussed today is alpha cross product of the r plus omega cross product of omega cross product of the r. This is tangential acceleration. This is the normal one. If you want to find the magnitude of these ones, the magnitude of acceleration, just multiply alpha by r. Or the magnitude of normal, it is omega squared r, as it was one question in previous slide. This is the vector form. From this, you can find the scalar form or the magnitude. Then, for a general plane motion, that is the combination of translation plus rotational motion. You learned that in previous lecture. For example, for a slider or a piston that's connecting using connecting rod to the crank. This point is A, this point is B. This crank has a rotational motion. This piston has a translational motion. This connecting rod has a general plane motion. Why? One side of this one has a translational, one side has a rotational, this one has a general plane motion. Now for this general plane motion, in previous lecture, we used one equation. What was the equation? This is the relative velocity between these 2 points. Velocity of the A equal to velocity of the B plus velocity of the A with respect to B. I explain and I'll show you how we found this equation. This is the velocity of the A from translational. This is the velocity of the B that has a rotational motion. And this relative one shows the relative velocity of the A with respect to B. That based on the view of the person that's just rotating, this one is a type of rotation. This term can be written as omega AB cross product of the R A with respect to B. Now, omega AB is the rotation of this one. It's the angular velocity of this link. RA with respect to B means that B wants to go to the A position. B wants to go to the A position. This is RA with respect to B. These are what we discussed in previous lecture. What I'm going to do for my first part and the half of the second part of today's lecture, I want to solve examples. These examples are important. Why? There will be one question in the final exam. Also, you have to solve examples for the homework. Any questions from previous lecture? I read your comments. Some of you asked about this velocity. I tried to explain. Some of you confused with the vectors and the magnitudes. Some of you talk about this equation that I start to talk about this one and what are these ones. Some of you just mentioned that you wanted to know what are these variables. As I mentioned, these are velocity. This is angular velocity. This is the relative distance of the A with respect to B. Got it? Any questions from previous lecture before I move to the next slide? Can I move to the next slide? Yes. Now, for the procedure for the analysis of the general rigid body, for example, this problem is given to you and ask you that if this crank OA rotates, we are looking to find the velocity of the B and also the angular velocity of this link. For this problem, to solve this, how we can solve, there are two solutions. One, we use the scalar analysis. This one's, in my opinion, it needs more practice for a scalar analysis. Based on my experiences, if you started to solve the problem in the vector analysis, when you solve more problems in the vector, then you can go to the scalar analysis. Let's start with the vector analysis. For example, for this problem that I will solve today, how we can start? First, you establish XY coordinate system. This is X, this is Y. Why? You need to write this quantities, VA, VB, RB, and omega in terms of the vector form. What's the vector? You need to write the vector in terms of the I and J components. And also, Z direction is perpendicular to this plane. Then, next step, we need to use this equation. This equation, each of these terms, this BB, for example, this is velocity of the B, this is velocity of the A, omega, and RB with respect to A, you need to write each term in terms of the vector form, as you show here. Then you put into this equation and find the unknowns using two scalar equations. How we can use these scalar equations? When you write this ones, left-hand side it's a vector. Right-hand side also it's a vector. As I mentioned, vector has I component and j component. This vector has I component and j component. You need to equal I components on both sides and equal j components. If you equal I component and j components, you can find the unknowns. As I mentioned, from this one, it's a vector. Vector has an ij component. Vector has an ij component. We need to just make the I components equal together and j components equal together. Apple with apple, kind of just orange with orange. Okay, guys? You cannot equal I components with the j component. Okay? Then, sometimes you will find some negative answers. Why is it negative? For example, for this one, you consider omega in this direction. However, when you solve this one, you will find omega, for example, -5 radian per second, for example. Means that the direction that you select is not correct. You need to return back, change the direction of the omega. This is the reason you have the omega as a negative. Now, when you solve these problems in the vector form, and you're familiar with the vector analysis, and then we can do scalar ones. Why scalar ones? Because when you use the scalar one, the first step is similar to the vector analysis. But for the second step, you already have in mind that this is x, this is y direction, and put x and the y direction of the VB, y direction of the VA, and y and x direction of the VB with respect to A, and solve the problems. This is the difference. My opinion, the vector form is much easier for you as a first step. Got it? Now, let's start to solve. First example. I distributed these papers. The reason some of you are writing, I don't want to spend time to write, draw those ones. Here, just focus how to solve. If you need any questions, you can ask me. For two examples that I gave to you, just I printed for you. You can write it without spending time. Or some of you have tablets, you have access to my notes and presentation, you can use your notes. Whatever you're convenient, you can use. Now, for this problem, the crank rotates this crank, OA. It is rotate with the angular velocity of 12 radian per second. We want to find the velocity of the B, this piston, and the angular velocity of this link, or this rod. Now, for this problem, as you saw, omega OA, it is 12 radian per second. You need to find the VB and the angular velocity of the AB. What's the plan for this type of problem? If you disassemble this mechanism, you will see there are three parts: one slider, one crank, one rod. The slider or the piston, B, just moving up and down. This one has a translational motion. Also, this crank, if you disassemble from this link and disconnect from the rod, this crank is just rotating over. Okay. Now, this one has a rotational motion. This rod or this link has a general plane motion. Now, for a rigid body that has a general plane motion, we will use this equation between these 2 points, A and the B. Velocity of the A equal to velocity of the B plus velocity of the A with respect to B, or velocity of the B plus omega AB cross product of the RA with respect to B. We will use this equation. Look, we will write this equation between these 2 points, A and B, for the general rigid body. I do not write this one between O and the B, or A and the O. I will write this one between A and B. These are 2 points for the general plane motion. Now, the next step, I want to write each of these terms in terms of the vector form. Can I move to the next slide? Yes? Yes. Now, for this problem, you will see that when this one is rotate, causing this one going upward, this is the velocity of the B. Also, this crank, when it's rotate at this instant, A can move along this curve path or this arc. At this instant, if this is X and the Y direction, what is the direction of the velocity at A point? What is the direction of velocity A? What's the direction of the A? Yes. Negative X direction. That's easy. Just when this is the path of the A, at this point, the velocity that is tangent to this path is in this direction. This is the direction of the velocity of the A. Also, I consider that this one, it's moving with the omega AB in this direction. If this one is, just imagine, if this one rotates this direction, causing this thing move, causing this one up, this one rotate this direction. This is the correct direction of the omega AB. However, do not worry, as I mentioned, if you just guess this one in opposite direction, you will find a negative number. Now, using that equation that I showed to you, velocity of the A equal to velocity of the B plus omega AB cross product of the RA with respect to B. I want to find 4 velocity vectors, 3 velocity vectors and 1 distance or the direction. Now, velocity of the A. Among these 3 ones, in my opinion, this vector is a difficult one. And also, I saw students struggle to find this. Next one that students struggle, this. Next one that students struggle, find the direction of the omega. Okay. Now, start with the velocity of the A. You know that velocity of the A will be in minus x direction or minus I direction. However, I want to find it. How? This crank rotates. Now, to find the velocity of the A, which equation should I use? When a rigid body rotates, what equations I can use to find the velocity? Yes. Correct. Yes. To find the velocity, you need to cross product of the omega. This omega, look. This is omega OA. This is not omega AB. Each of these links has different omega mic. Do not just confuse, put omega AB for VA. Also, this is a mistake I have seen from my previous student. Each one of them have different and distinct angular velocity. Omega AB, cross product of the R OA. Now, I will explain in details, but I will show you might be some students, their tricks or how they can solve or other ones. For this one, what is the omega OA in vector form? 12? 12K, correct. This one, look, A is rotating. My charm shows the direction of omega. Based on your paper that you have, if you curl your forefinger, this is the direction of the omega. It is perpendicular to this plane. This is Z. If it's in the opposite, it should be minus K. Then, the direction of the ROA, this should be this direction. This. If I want to write the ROA in terms of the vector, what should I write? This. Yes.
It's R J hat.
J hat. Okay. Yes. This one, it is 0.3 J dash. Now, some of the students ask me that, Professor, why is not this direction? Also, I saw from the previous students' solutions, they confuse, especially they will write those ones in the exam. I do not know, maybe their problem will appear in the exam. Which direction is correct? I want to explain this. This is another trick. You can write, look, this is the crank. There are 2 points, O and A. You can write the relative velocity between these two ones. This is another trick. How? Velocity of the A. Here, instead of the B, write O. Velocity of the O plus omega AO or OA cross product of the R A with respect to O. Just instead of the B, I just write O. Now, What is the velocity of the pin? How much is it? Yes. No, velocity of the O. Velocity of the pin. Does pin move? No. 0. This is exactly same as this one. Just if you can see, this is OA, and from this you can find that O goes to the A position. This is the correct answer, the red one, not the purple one. This is, I saw that I learned from student work. Some of them, they use this one. Also, I learned from how you solve the problems. Some students, as I mentioned, to find this correct or this one, use this trick. Is it good in trick? Yes? Now, here, if you calculate this one, look guys, to calculate, multiply the constant ones, then K by J, you have here, K by J is minus I. It is 3.6 minus I. You will see that I found the velocity of the A minus I, exactly consistent with the direction of the velocity I just guessed for the kinematic diagram. It's 3.6 minus I. Also, some of the students, they do not want to do this whole process. You saw that this is the direction, minus I, the magnitude is omega r, 3.12 multiplied 3 is 0.3. They will write 3.6 minus I, and they will do not do this process. It depends to you. Got it? As I mentioned, some of the students mentioned that this is the velocity direction, it's minus I. This is the direction. What's the magnitude? Is omega r. We have omega 12. R is 0.3. It is minus 0.3 I. Minus 3.6 I. It depends. I'm looking for this answer. How you find it? Except that look at your neighbors. It's okay. Any questions? This is the first one that students struggle. Any question, guys? No? Okay. Then the next one. Tell me quickly. How can I write the velocity of the B, this piston? The magnitude is unknown. How can I write the velocity of the B? Tell me. Any students? Yes.
Is it the angular velocity of A times B crossed into R neighboring perspective?
This is easy. This one is just moving up and down. We do not need to use any equations. What's the velocity of the B? How can I write it? I need to just look around 36. How can I write this velocity? What's the magnitude of this velocity? VB is unknown. What's the direction? What's the direction of piston? Yes.
J.
J. J. Easy. It's the VB J. I ask you simple questions. If you like difficult one, I can also ask. Now, the next one, omega AB. This one. Omega AB, we do not have the magnitude. What's the direction of the omega AB? Tell me quickly. Yes. K. Correct. This is the easiest. Go to the next challenging one. This is the second challenging one that students struggle. To find the RA with respect to B means that B wants to go to the A position. Okay? People with lower rank wants to get higher rank and higher salary. Okay? If you want to get, and also reverse of this one, let me know. I'm looking for students for call, pay low. My lab. Now to write the RA with respect to B, I will move to this slide. Let me just write. Means that RA with respect to B means that B wants to go to the A position. This one. This is RA with respect to B. Or this vector. That length of this vector is 0.3. The angle with the horizontal one is 30 degrees. Now, if I want to write RA with respect to B, how can I write this vector? How can I write this vector? This vector. The length of this vector is 0.3. The angle with the horizontal is 30 degrees. How can I write this vector? How? Yes?
Break it down into a sine and cosine. With cosine being 0.6 cosine 3 times negative I in basic correct. And then 0.6 sine 30 J.
Yes, exactly. Correct. This one has two components. One along the x, along this is 0.6 cosine 30. Along the y, it is 0.6 sine 30. To write this one, I can write this one. 0.6 cosine 30 in minus I direction. This is in opposite direction of the x. Look, this is x positive. This is in opposite direction. It is minus I. Also, this is along the j, just 0.6 sine 30. Easy. Now I found four vectors. This. Then move to next slide. Yes. If you want me to stop, just let me know. Okay. Now I will write again for some of you also following. VA equal to VB plus omega AB cross product of the RA with respect to B. VA it is minus 3.6 I. VB is the VB in J direction. Omega AB is omega AB K. RAB it is minus 0.6 cosine 30I plus 0.6 sine 30J. This is for this, this is for this, this is for this, and this is for this. Now, we need to multiply this inside of the brackets, then equal I components, J components, and that's it. Let's do. Oh. Now, I will write the I components with the blue color. J components with the red one. Then, also this by this will be J. How? Just this will be minus 0.6 cosine 30, oh no, minus 0.6 omega AB cosine 30. I just multiply the coefficients. Then K by I, as you can see, it is J. The next term is this one. This multiplied by this. That will be 0.6 omega AB sine 30 K by J, it is minus I. I will equal I components, blue ones, and equal the J components. How? Minus 3.6. Look, we have one I, one I. Minus 3.6 equal to 0.6. Okay, now this is 0.6 omega AB, oh no, 0.6 omega AB sine 30 also J components. There is no J component left hand side. I will write 0J. 0 equal to BB minus 0.6 omega AB cosine 30. Now, if you calculate this one, from this, you can find the omega AB, 12 radian per second. Then substitute this to this, you can find the VB, if you calculate 1.11 meter per second. This is the answer. This is the answer. Any questions? Any questions? No? No questions? Okay, let's have 5 minutes break. I want a fresh mind for the next exam. Hello. Did you convert that into zero? So that's not the
Oh, I can do it.
Yes. There's different type that shows the vector. You can write the atoms, you can write the some of them write them in the vector and the dot.
Oh, okay. Thank you.
That's right. Question? Yes.
Yeah, two questions. Number one, do we have any more assessments for the rest of the term? Test your quizzes.
Sorry.
Do we have any more test your quizzes over the final for the rest of the term?
Yes, we have finals.
Other than finals?
Other than finals.
Okay. And then about the test, do you know when those it's possible when those can be confirmed?
For the exam two,
Yeah.
I do not know. Sorry, I couldn't explain. I just explained. I just I graded 2 or 3 out of 5 questions for all students.
Oh,
When
okay.
I try, I will put the question 1, just grade question 2, grade question 3.
Okay.
I just grade 3 out of 5. There are 2 remains 4 and 5. I have to grade. During my weekends, I will just grade them. So you will see in the blackboard. Then I will show this grades also bring those papers as well.
Okay, so then so the grades should be in by this
Yeah.
weekend.
Yes.
Perfect. Thank you.
Yeah. Here. Okay. Let's resume the second part of the class. Any question from the first question? Would you please correct this velocity? I just calculate the velocity based on the calculator of mine. It was in radians, not degrees. Would you please correct this velocity? The velocity of the B is 6.23 meter per second. Any questions? No? Okay. Now, second example. If the block at C is moving downward at 4 foot per second, the angular velocity of the bar, bar AB at the instant shown, we need to find the angular velocity. Now, for this example, here, the velocity of the C, it is given if we select xy coordinate system look like this. Velocity of the C, it is 4 foot per second downward. As you can see, it is in minus j direction. Then, what we are looking for? We are looking for to find omega AB. Then, the solution. We need to write the relative velocity equation for a kind of rigid body that has a general plane motion. Now, one of you, can you tell me between which point should I write the relative velocity equation? Which point? AB, BC, AC. Which ones? Between which points should I write the relative velocity equation? Yes.
BC.
BC. Other students, do you agree or do you have different opinion? Do you agree? Yes. We need to write the equation between B and C. Why? This is the one that has a general plane motion. To write the equation of the motion, VB equal to VC plus omega BC cross product of the RB with respect to C. Some of you might be asked that how this one is coming from or how we can write. Look, this equation in the exam, it is given to you. Now, what you can do, instead of A, just write B. Instead of the B, write C. And then, exactly, omega AB will be BC, omega AB will be BC. Just change the index. Got it? For example, do not raise your hand in the exam that, professor, you didn't provide the equation for the link between B and C. Got it? This is how you can write. Then, we need to find 4 vectors, VB, VC, omega BC, and RB with respect to C. Let's start with the easiest one. Then a little difficult one. Which one do you like? Start with the difficult or start with the easy one? Easy? Easy. Easy one. Look, the velocity of the C, it is given. Minus 4G. This, check mark. Then omega BC. Look, if this one is moving downward, also this is, I consider, this is omega BC. I can write omega BC as omega BC minus K dash. Now, this is check mark. Next, velocity of the B. This is a crank, okay? This is rotating on. Velocity of the B. What is the direction of the velocity of the B? Downward. Is it correct? Means that in minus J direction, right? Do you agree? Yes, everybody. Look, this is like going down. At this point, this is the velocity. It's downward. The velocity of the B is downward. This is one trick. For example, at here, this is downward. I can write this is minus J. And the magnitude of the velocity of the B. How much is it? How much is the magnitude of velocity of the B? How much? E minus J. For this one, I just mentioned this is minus J. But how much is the magnitude of this? Yes. Omega AB multiplied by 2, because this is the direction. But this is the easiest way. Just here, we consider this is downward. We can write this one minus G. And then this magnitude will be omega AB multiplied by 2, or 2 omega AB. Or some of you, you do not know the direction, you do not know the magnitude, and you want to know. This is the second solution for this one. You can write this one as omega AB cross product of the RAB. Some of you, you are not sure about the direction, you are not sure about the magnitude. We need to use this equation. Omega AB, as you can see, it is omega AB minus K dash. Cross product, this is cross product. RAB is look like this. Just draw a vector from the P to the B point that is rotating. This will be 2I. Now, this one will be minus 2 omega AB, then K cross product of the I. K cross product of the I, it is J. Here. Look, this one is same as this. Some of you, you do not know the direction, the magnitude. Just write in the general form. You have to find exact same one. Now, check mark. The last one is RB with respect to C. Means that C wants to go to the B position. This is the vector. If you're right, I want to go to the next slide. Can you move to the next slide? No. Or tell me here until you're right. This is the vector. The magnitude of this one is 3. The angle, it is 30 degrees. What is this one? What is this one? What is the x component? What is the y component? Leo, how about this? What's the x component? 3 cosine 30. Okay. What's the y component? 3. Yes. This one is 3 cosine 30. This one it is 3 sine 30. Both are in negative directions. I will write this one next slide. Or if you agree, I use this space. Can I write here? Sometimes I got some feedback. Some students mentioned that we do not like to write at the bottom lines. It is minus 3 cosine 30i minus 3 sine 30j. Check mark. Now I found 4 vectors. What I need to do, just substitute into this equation equal I component, j components. Can I move to the next slide? Yes. Now, from this equation, oh, VB it is minus 2 omega AB J diversion. VC it is minus 4J. Omega BC it is minus omega BC K cross product of the minus 3 cosine 30i minus 3 sine 30j. I just substitute previous vectors we found. Here, again, I write the j component with red color. Then this by this, it is 3 omega BC cosine 30. K by I, it is J. And this by this, mine plus 3 omega BC sine 30 K by J minus I. I just write the I component with blue color, J component with the red color. Tell me quickly, how much is omega BC? Omega BC. How much is it? Yes?
2.
2. Okay. Other students? How much is omega BC? Yes. You.
Oh, no, it's reason.
Okay. How much is omega BC? Calculate. I will calculate this one in 3 seconds. How much? Zero. It's 0. Why? You have apple on the right-hand side. Left-hand side is 0. Means that this one should be 0. The I component equal on the both sides. There is no I component left-hand side. Is there any blue color on left-hand side? No. This will be 0. Or zero equal to 3 omega BC sine 30. From this, we can conclude omega BC 0 radian per second. Then, how much is omega AB? Yes, 2. Correct. I call the J component minus 2 omega AB equal minus 4 plus 3 omega BC cosine 30. Just I write this coefficient. Left-hand side equal to right-hand side. This term is 0. Why? We found in previous equation. Minus 2 omega AB equal to minus 4. Omega AB, it is 2 radian per second. This is the answer. Any questions? Any questions? Any question, guys? No? It's an afternoon class, and I can see students are sleeping. Let's give you 5 minutes. I want to start a new lecture, and that's the reason I need a fresh mind. Okay, I do not want to sleep during my third one. Let's stretch, walk, drink your water. Look, this one is very important. This is orientation. This one is orientation.
Is it within the him?
Yeah.
And then this one's general because it's between the two? Thank you.
I leave it. Let's resume the second. Okay, now, for the last part of today's lecture, I'm going to talk about the planar kinetic equation of the motion. This is the last part for this course. We'll focus on the kinetics of the rigid body. And first, I'm going to talk about the equation of the motion for a translation. Then I will show you the equation of the motion for a rotational. And finally, for the general plane motion. As you can see here, we want to apply the equation of the motion. We have three equations of the motion along x, y, z for a rigid body. And for the first part, we will focus on the translational motion, such as a car just moving along x, y, and z, or for example, this landing gear, or this one, this airplane wants to just land. And for this one, we will use the free body diagram as we did it for the particle. We will use same equation of the motion, but a little difference. Finally, for the translational motion, I will explain. We need one more equation that I will show you today, and also we have time for trying. Now, previous lecture, I talked about kinematics. What we found, the velocity and the acceleration for the rigid body. For the previous lecture and previous session, the force does not apply. Now, we want to apply the force, as you can see. For example, here is this tires for the airplane when it's landing. And you can see several forces apply while this tire rotated simultaneously is translated. And the procedure is that we draw the free body diagram as we did it for the particle. We apply the equation of the motion. And what is different in here that we also need to consider the angular acceleration. As you can see on these examples, for example, we want to know that how much is the frictional force for this landing gears for the airplane, and or what is the forces needed to push this refrigerator, or for this person sitting in this car and wants to move, how much torque is needed to move this one forward. These are what we can find from these applications. Also, one more application, just we solve one example. If you remember, for a boat that is towing by a truck, similar one, but here, what's the difference in here? You will see that if I draw the free body diagram for this one, I apply the weight on the center of the gravity. And also, these normal forces, instead of we apply all of the force on one point, for a rigid body, we will apply them on when they apply on the surfaces. For example, weight is applied to the center of gravity, A and B, normal forces apply A and B, and also you can see the traction force or the tension. Also, one more thing, guys, you can see that here we have this inertial force that applies to the center of the gravity, and this force has a distance from the surface. If you remember, just for a particle, we just consider this only a particle. We apply weight, normal force, the frictional force. And then when I ask you to draw the kinetic diagram, you just apply this one like this. Because the particle doesn't have size, we cannot consider the inertial force on the center of the gravity. And also, this inertial force has a distance, you can see, from the surface of the ground. Now, This is from the chapter 17, section 2 of Hibber's book. And also, if you want, you can refer to the, I think, chapter 5 of the Merriam book, similar contents. What we were going to do, and also what we will consider, this is a general rigid body. This general body, it has a general plane motion. It has a translation plus rotation. And we consider a coordinate system, XY coordinate system, that do not rotate. And this is fixed. It translates with the body. And for this general rigid body, these are applied. What are these? F1, F2, and F3, and F4, they are external forces. M1 and M2, what do you think they are? What are they? What do you think? Yes. Moments. Yes, correct. These are external moments. Omega, it's the angular velocity. Omega. Alpha is the angular acceleration. This is a general rigid body. For this one example can be a car. That's weight, normal force, and the frictional force applied. These are the role of these forces. Also, for example, consider I apply a moment in the front of the wheel. And this starting to rotate, alpha and omega. For example. Or one another example is the tire. They test the tires and they apply a torque to the tire that this tire can rotate with angular acceleration and velocity of omega and alpha, while this normal force and the weight and the frictional force is applied to the tire. This is one example that we have the external forces, we have a moment, we have alpha, we have omega. This is a general one. Now, for these cases, how we can relate this with these forces? With the external one, with the torsions, and with the moments. How we can relate them? Now, first, we want to write the equation of the motion for a translational motion. What does it mean? It means that, for example, there's a car. This car is moving to the right. This is an example for a rigid body that has a translational motion. Now, for this car, how we can write the equation of the motion? First, for this general case, as we can see, several external forces apply, and we have the weight, we have the normal, we have the moments, and also these are the inertial forces along x and the y directions. If you remember the equation of the motion for a particle, it was sigma f equal to ma. I use this one for the equation of the motion. However, this was only for one particle. How about the rigid body that consists of several particles? How we can write this equation? To write this equation, we will write sigma f equal to m. Now here is m is the total mass of the rigid body. Instead of this acceleration, that just consider this acceleration for each of these particles, we will apply the acceleration on center of the we will apply the acceleration on center of the mass. Instead of applying on each of these particles, I will apply this acceleration on the center of the mass, or acceleration on G. Now, similar to this equation for one particle, however, one difference is that we apply the acceleration on center of the mass. Then I can develop this one along the x and the y direction. Sigma fx equal to m ag along the x, or the acceleration of the center of the mass along the x, and sigma fy equal to mass acceleration of the g along the y direction. These are two equations for the rigid body that has a translational motion. Now, can I move to the next slide? Oh. One general example to how to use the equation of the motion for a car. It's a car. Now, on this one, I want to show the free body diagram. Also, separate diagram. I want to show this one for the kinetic diagram. For this car, this is the center of the gravity, or center of the mass. This weight applied on the center of the mass, instead of just considering the mass of each part and then combine them together, we can apply the weight on the center of the mass. This one, also we have center of the mass, same line, just here. Let's show the forces applied on this car. This car is moving in this direction. We neglect the mass of the tires, or we consider the mass of them on total mass of the car. Then, these are the normal forces. On front, normal force. On the rear, okay. Also, if this one is moving this is the frictional force of the rear. This is the frictional force of the front. For kinetic diagram, we need to show mass multiplied by acceleration. What? MAG along the x, m, the acceleration of center of the mass along the y direction. Is there any strange forces in here? Something that is not look as it is. Which force? Yes.
So, just seeing the drawing, the first moving to the right.
Yes.
Is that good? Friction forces?
That's the point. Look, for this one, now we have the tire, it's a rigid body. It's a rotating. Okay? Now, previous one, we consider this one as a one particle. When this one moving to the right, the frictional force is in the opposite direction. However, here we have the tires. Tires are rotating. Okay? When this one are rotate at the contact point, this is the velocity vector toward the left. Means that the frictional force will be opposite. This is the point of this probe. Now, for the rigid body, because now it has a size, this one is rotating. Yes, I hear exactly for the first review question. This one is the velocity will be at this direction. The frictional force will be in opposite direction. Yes, if the car is sliding, for example, just if you push the brake, you're driving on ice, just you're sliding, yes, the frictional force will be opposite. However, in the real world, just this one is rotating, and here, this is the velocity, frictional force will be opposite. Got it? This is the point. Now, we have this forces, external forces, we have this moments. We need to use these equations I show you here. Summation of the forces along the x equal magx. Summation of the force along the y equal magy. Left-hand side, look at the free body diagram. Right-hand side, look at the kinetic diagram. Summation of the forces along the x equal to magx. Summation of the forces along the y equal to magy. Look, left, left, right, right. As you can see, I need to write the equations, forces along the x. We have two forces. Frictional force of the rear plus frictional force of the front equal to magx, or this one is the mu, normal force of rear, plus mu, normal force of the front, equal to magx. One equation. Next one. Along the y direction, normal force of front plus normal force of the rear minus weight equal to, if this car is moving along the x direction only, how much is the acceleration of the g along the y? 0. Yes. This is equal to 0. Now, from this equation, as you can see, we have this one is unknown, this one. Now, we have two equations, but three unknown. We need one more equation. That equation, I will show you on the next slide. Now, what is that equation? Got it? When I came to United States in 2020, I have to go to the immigration office in Detroit, Jefferson Avenue in Detroit, if I'm correct. And I had a car. It was during the COVID time, and we have to do and to go to the interview and those fingerprinting and those things. There was an accident. Always in Detroit, there was an accident. I used the Google map, showed me the map. It just passed me through different streets, and suddenly we passed through a kind of a purple big SUV. It was parked at the kind of side of the street, and the music volume was high, and it was bouncing. And the smoke coming out of this one, it was our first impression from the Detroit area, from my side, and also my wife. At that moment, she was pregnant, and she's scared, because it was a kind of huge one, and it was a kind of the suspension system comes off, and it was a kind of tall, big one. For that car, we have the acceleration along the y direction. I never saw that one again. That was my first impression. I never been in Detroit. For example, 6 months I live in Grand Blanc, and then I just come down to the Detroit area and those things. This is my first impression from Detroit. Got it? Do you have those cars? Any of you? No? No? Okay. Now, these are the equation of the motion for a translational motion. Just a car is moving here. How about the equation of the motion for a rotating body, such as a tire? Tire is rotating, only tire. Okay? How about the tire? How we can write the equation of the motion for a tire that is rotating? For this one, we need to use this equation. What is this equation? I will explain. This equation can be used only for a rotational motion. To write this equation, I will find the moment of the forces about the point P. You will see here, we have this point P. These are the forces. Then we will find the moment of these forces about the point P. Before go, review. We have a bar or a beam. I apply force of F. There is a distance of L from the support. Now, if I want to find the moment at the support, how much is the moment? What's the moment? Force? Distance, correct. Force times distance. Force multiplied by L. Then, if I apply one external moment at the tip of the beam or at the tip of the bar, now, what should I add here? For example, this one is M0. This one also, I apply M0 because we add a moment at the tip of the spin. Now, for this one, we want to find the moment of the all forces about the P. This one, it's a moment of external forces. R multiplied by F. It looks like this. Distance multiplied by force. What's I? And because there are several forces, such as weight, the distance of the weight from the point P multiplied weight. For example, if we have normal force, the distance from this point multiplied by normal force. This is how we can find. This is the first expression. Second expression, it is the external moments. Such as this. These are all external moments. Or for this general one, we have M1 and M2. Just summation of M1 and M2. These are two expressions. Then, right-hand side, what are these ones? The easiest one are this. Left-hand side, I will look at the free body diagram. Right-hand side, I will look to the kinetic diagram. For the kinetic diagram, we have two inertial force. Inertial force it's mass multiplied by acceleration. For this case, we have mAgx, we have mAgy. The acceleration, the moment of the inertial force along x, inertial force along the y direction. Also, these forces, they have moments about the point P, for example. For example, this is the inertial force. This one has a distance of x bar from P. This one is an mAgx. This one has a distance of y bar about the P. And this is how we can find the moment. This one, it is the moment of inertial forces. Now, this term, what is this one? This one is because of the rotation. Now, I want to explain what is I, it is called. Okay? Can I move to the next slide? We have one more slide and then we can go. Two more slides. I is called mass moment of the inertia. How we can find the I? I, it is mass moment of the inertia. For example, consider a rigid body look like this. We apply a torque. For example, this is the rigid body I have. I apply a torque to rotate this one. T is the torque applied to this. Then, if I apply a torque such as a tire, I apply the tire torque of T, tire can be rotated with the angular acceleration of alpha. Then, if I want to relate T with the alpha, we can use this equation. T is equal to I multiplied by alpha. This one is similar to this. F equal to mass multiplied by acceleration. The definition for the I is the resistance of a body for a rotation. For example, look, I have two cylinders, look like this. This one, the radius of this one is more than this one. Okay? If I apply a same torque means that to rotate. Which one is more difficult to rotate? This one. Means that this one has I, or mass moment of the inertia, more than this one. similar to this. I have two tables. This has mass of this one is more than this table. If I want to apply a kind of force, same force on this one has more resistance of this one. Why? The mass of this one is more than the mass of this table. The role of M in here in this equation is I. The role of the F is T because we have rotation. The role of the acceleration is alpha. Why? Because we have rotation. This one is called mass moment of the inertia. And then we have two slides more. We do not have time for today, but this is why I want to stop. Any questions? One more slide, then we can go. No? The deadline for the homework 8, it is tonight. Please do not remember to upload your homework 8. Also, I upload homework 9, but this one has 1 week until next week. This homework, it consists of 2 parts. First part, you can solve it because I solved most of them. For example, this one is a general plane motion. As I solved 2 examples. The next part is the equation of the motion for a translational motion. For this one, I need to solve examples. Please solve this one first. For some of you, you want to do homework. Then the next one, when I solve on next Monday, you can have more examples. But those equations will be easy. But please work on the half of this one. Then I will give another one and more examples next Monday that you can submit on Thursday. Thank you for the coming to class. Having a wonderful weekend. Take care of yourself. See you on next Monday.
Professor, when you get a moment, when you help me out, basically write down what evaluations I need to do. I think that's probably yeah. For this one, I'll use this like that. Also, when you find the omega, you can find the velocity. How you can find the this is our song. Yep. Yeah, I got that one. Okay. This one is similar to this one. Yeah, you just saw the here. Also, and great for a second. I woke up. I watched it. Yes. I did. I wanted to see if I this equation. I don't think
Really fry plus.
I need to charge this to actually signal.
Yes, right.
Right.
Yes, the same computer.
I thought you were sweaty.
This is the equation.
Yeah, that's I'm crazy. It's a like.
I do not check the numbers.
Well,
While
that's
we are
a-
in good track.
Okay, I'm just wondering about the equation.
No, that's good.
Yeah, that's fine.
It's similar to this one I gave you in the similar
This
practical.
goes out to me.
And that's, how do you find the alpha?
I thought it was facing the
Alpha
other
is
way.
good.
This is
Yeah.
Sorry.
Other questions?
No, I just
Yeah,
wanted to.
I was just
No,
worried
no,
that
no.
was easy.
Thank you, sir. Good job. I'm trying. Yes, good.
But I didn't see feel the ground. So now I need the third one.
It's usually not a good network.
Which they did make it. Am I allowed to slap you?
You have the,
No.
the alpha.
We had sun, rain, and snow or Tuesday, whatever day. Yeah.
Yeah, but while he was gone.
Here's where it has all that. Yeah, that's like ground region. It's not up to.
Now,
Hey, what we could do is.
R is 100.
I think we would go like. Yeah, like that.
No, this one, because we have both sides.
We could have cables, as long as it's disconnected.
Oh, okay.
Okay.
Just delete those. I like to see the circles.
Cables.
Just right as your.
Yeah. Okay. Cables are like. With gravel. You also contact them. Hey, we really just put both of them on the ground.
Isn't it possible to do it like this though?
Yeah.
Like without, I mean, because with this, that's what I'm confused about.
No, look, we have the omega. We do not have omega B, but we have RA and RB.
Okay, but because you gave me the acceleration, you wanted to solve it this way.
Yeah, just for this one, I didn't know that we do not need this. I saw this.
Okay.
We do not need alpha.
Okay.
We have the alpha. Omega.
Okay.
Ready?
Started.
Ready?
You don't like free stuff?
I'm not great. Well, I'm better at put plywood up. Oh, yeah. Put plywood up.
Have a nice weekend.
You too, thank you.
Yeah, we could apply.